Thank you for joining us for the second part of our video for Module 2B, Day 2, working with arithmetic sequences and with their partial sums. So let's say that in 1960, the average cost of a loaf of bread was 23 cents, and it was about 22 or 23 cents back in 1960. This amount has increased by approximately 0.018 cents yearly, so almost by 2 cents yearly. Determine how much you would expect to pay for a loaf of bread in the year 2030. Well, let's set up a relationship. I can say that my nth term, right, that my nth term of my sequence, if I'm going to add about 2 cents each year, is going to be given by 0.018n, right? And then I'll say plus 0.23, but I'm going to define this to be where n is greater than or equal to 0. That way, year 0, right? That way, year 0 is 1960, right? So in 1961, right, 1961 would be essentially at the end of my first year, and the expected value there would have been 0.018 times 1 plus 0.023, not 0.0, plus 0.23. And if I were to look at that sum on a calculator, 0.018 times 1 plus 0.23, it gives me that I'd be at about 25 cents. So I'd say, hey, a sub 1 is approximately 25 cents. All right, but I want the year 2030. So from 1960 to 1940, or to the year 2000, that's going to be 40 years. And then to 2030 is going to give me another 30 years, right? So I'm going to be looking at a sub 70, and a sub 70 would be 0.018 times 70 plus 0.23. And if I do that value, 0.018 times 70 plus 0.23, that gives me approximately $1.49. All right, so it'll cost me, in theory, in the year 2030, approximately $1.49 if I had this constant rate of growth of almost 2 cents a year for the cost of a loaf of bread. I think that you'd notice that a loaf of bread may cost a bit more than $1.49 now. And so we could say, how valid is this as an estimator? But it is still an example of a use of an arithmetic sequence in determining values. Okay. So next we're asked for the 150th partial sum of the arithmetic sequence. What does that mean? It means that I want the sum of the first 150 terms. How am I going to find the sum of the first 150 terms? I'm going to take the number of terms I have divided by 2, right, and then add to it my first term and my last term. Well, I know that my first term is 5. I have to figure out the last term. Well, what's a sub 150? Well, let's look at what my pattern is. What am I doing? Each time it looks to be that I am adding 11. So my 150th term is going to be 11 times 150, right? And then minus 6. Why minus 6? Well, what's my first term? It's going to be 11 times 1 minus 6 to get me 5. So 11 times 150 minus 6, 11 times 150 minus 6 gives me 1644. So that's going to be 1644. So what's going to be my sum of the first 150 terms? My 150th partial sum will be 150 divided by 2, which is 75, times the first term plus the last term. And if I use my calculator, right, let's add 5 to 1644. take that number and multiply it by 75, and that number would be 123,675. Right, so it is going to be important to know how to use our calculator and know how to set things up. Once again, very useful formula, like we said, is the sum of the first n terms is going to be the number of terms divided by 2 multiplied by the first term plus the last term. Okay, what if I want to find the sum of two-digit multiples of 3? So multiples of 3. What's going to be my first two-digit multiple of 3? It's going to be 12. What's going to be my next one? 15. My next one, 18. And I'm going to go on and on until I get to 99, which will be my last multiple of 3. What does this mean? It means that I have something that's arithmetic, right? And I would have a sub n is equal to 3n plus 9. Why plus 9? Well, because if n is equal to 1, and we said we'll start at 1 unless we specify otherwise. So if n is equal to 1, we know that a sub 1 is going to be 3 times 1 plus 9, which is going to be 12. All right, so let's make this computation. How many terms would I have to get to 99? Because I need to know how many terms I'm going to have. All right, a way to do that is to say 99 minus 12 divided by 3. And if I look at 99 minus 12, and I take that number and divide it by 3, that's equal to 29, and I know that that's going to be n minus 1. How do I know it's going to be n minus 1? Well, because I know that my nth term is going to be my first term plus my common difference, in this case 3, times n minus 1. So if I take 99 minus my first term divided by 3, I get n minus 1. So that means that n is equal to 30 in this case. So what's going to be the sum? The sum of the first 30 is going to be 30 over 2 times my first term plus my last term. All right, so 12 plus 99 times 30 divided by 2, and that gives me 1665. All right, of course, if I said 15 times 12 plus 99, I should end up with the same thing. How you approach it is up to you, and please make sure that it is clear where your answer is. All right, let's continue with another couple of questions to wrap this up. So, consider a job offer with a starting salary of $45,239, annual raises of $2,750. Determine your total compensation through 6 full years of employment. So, my first salary, $45,239. All right, then my next salary is going to be $45,239 plus $2,750. That gives me $47,000, right, and $989, right? And I'm going to go all the way till I get to my 6th year. Well, how am I going to get to my 6th year? Well, after 1 year, I add $1, right? So this is, right, 1 year, then 2 year, then 3 year, then 4 year, right? Then I'm going to have 5 year, then I'm going to have my 6th year. How many times am I going to add 2750 to get to my 6th year? I'm going to add it 5 times. So I'll have 2750 times 5, right, plus my initial salary of $45,239, which gives me, right, that last value of 58,000, or yes, 58,989. So if I want my total compensation, that means I want the sum for the entirety of those 6 years. It's going to be 6 over 2 times my first year's salary, $45,239, plus my last year's salary, $58,989. If I use my calculator, $58,989 plus $45,239. All right, take that number and multiply it by 3. that means that in 6 years I had a total compensation of $312,000 or $312,684. All right, so not a bad compensation package, but certainly it's something that you may be able to do better than. And our last problem, looking at a little bit of applications of these arithmetic sequences and series, right? A formal garden has shrubs planted inside a grid consisting of 14 rows. The first row has 15 shrubs, the second row has 18 shrubs, the third 21, and so on, right? Write an equation expressing the number of shrubs in a row, and then hence find the number of shrubs in the ninth row and the total number of shrubs in the rows. So we need to think about what this is going to represent. So I want to be able to figure out how much I have in my ninth row. I need to figure out how much I have in my 14th row because I have a total of 14 rows. And I want to figure out my total sum. So quite a few things that are working here. So let's start. A sub n, I could say, is 3n plus 12. That'll give me 15 as my first term, 18 as my second term. That means that a sub 14 is going to be 3 times 14 plus 12. And 3 times 14 plus 12 is equal to 54. I know that my ninth term is going to be 3 times 9 plus 12. 3 times 9 plus 12, that gives me 39. And so I know that I have 39 in my ninth row. Got that done. Equation expressing the number of shrubs in a row, that's how many shrubs I have in a row. Right, my first row is given by, so I have that equation. And I will need the total number of shrubs. So really I'm saying I need 15 plus 18 plus 21 plus dot 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 all the way to plus 39 that I had in my, or excuse me, plus 54 that I had in my last row. All right, so I want this summation, right, this series summation. How can I do it? One way is to write this using summation notation. And I could say, hey, the sum from k is equal to from 1 to 14 because I have 14 rows. And my formula is 3k plus 12, right? And I want to make sure that my counter matches. And I can come to, and let's go to my calculator, go to my toolbox, go to calculus, arrow down to my summation, and I'm going to go from 1 to 14 of 3 times my counter plus 12, and so that gives me a total of 483 shrubs. All right, so I've got a total of 483 shrubs. Is that the only way? No, because I could have used my formula. Right? Hey, that the sum of the first 14 is going to be my 14 divided by 2, my first term 15, plus my last term 54. And if I did that on my calculator, 15 plus 54, right, multiply that number by 7, and notice that regardless of how we did it, we got to the same answer. Which way should you use? The way that you're more comfortable. All right. If you're more comfortable using summation notation and using your calculator, use summation notation. If you're more comfortable using the formula for the sum of an arithmetic sequence or series, then use the formula. Either way, you should show the work that you're using and be competent with your calculator to make those computations. I appreciate your time. Thank you very much. Come back for additional help as you need. Bye-bye.